Hello and welcome. In this video, I'll be working through the solutions for your test review over chapters 6 and 8. While working through this, I'd recommend you maybe have a graphing calculator somewhere nearby. Make sure that your mode is in degrees before we get started. But yeah, without further ado, we'll go ahead and get right on in. With problem 1 here, notice it's providing a picture for us. All three sides have been labeled, but one possible version of this is maybe if I only give you two sides, use Pythagorean theorem to come up with a third. This, again, though, is kind of nice. It's given us a 7, 24, 25 Pythagorean triple. So this is really just assessing, can we come up with each of the ratios that would be in relation to the angle they're referencing, which it looks like for all of these, it's referencing this angle T, which is down here in the bottom right. So at this point, it might be beneficial to just say which was the opposite side, which was the adjacent, and which is the hypotenuse. So opposite is all the way across the shape. Adjacent would be the one next to it, and the hypotenuse is the longest, or the one across from the 90. So at this point, it would just be, let's go ahead and figure out what each of those ratios are. So from SOHCAHTOA, which if it helps, you can always write next to the problem as well, as I've done here. And sine would be the opposite over the hypotenuse, so that would be 7 over 25. Cosine is adjacent over hypotenuse, so that would be 24 over 25. And tangent is the opposite over the adjacent, so 7 over 24. The other three, which are a little bit newer for all of us, are just the reciprocals of each of those. So sine's reciprocal is cosecant. So if sine was 7 over 25, cosecant must be 25 over 7. Secant is the reciprocal of cosine, so since that was 24 over 25, this must be 25 over 24. And cotangent is the reciprocal of tangent, so that would be a 24 over 7, just referencing that 7 over 24 from before. If any of these, just kind of take note, if any of those happen to have a radical, just be mindful of we may need to do some rationalizing, which recall that means just get any denominators to no longer have a radical on them. And the way we would do that is just multiply by whatever that radical is on top and bottom and simplify as needed. All right, moving on to the next group. This one now for numbers 2 and 3 is just a part where it's assessing, do we remember what the special right triangles are? In other words, the 45, 45, 90, as well as the 30, 60, 90. Important to note here, it does say exact values, so that basically is saying I don't want any decimals. I want, if it's going to be in fraction form, to be a reduced fraction. And if I have radicals as part of any of the sides, which both of these do have at least a side with a radical, make sure you keep it in that radical form, but again, still reduced as needed. So I'll go ahead and just draw each of these triangles underneath. Each of these, it's not going to be perfect to scale, but as far as just getting the point across, that would be my 45, 45, 90. And if you recall, the ratio of the sides would be like t, t, and t square root 2. So if I don't want to have that square root be a part of that hypotenuse, as we have here, I could just say, let's let t equal the square root of 2. That way, square root of 2 times square root of 2 turns into a regular 2. So I'm going to go ahead and do that and just say that these two sides here are going to be what I want to be square root of 2, which then makes the hypotenuse square root of 2 times square root of 2, which is just a regular 2. Reason why I would maybe want to do that is just to make it a little bit easier to simplify, because if I have to divide by a radical, then I'd have to rationalize, which adds an extra step later that maybe I don't necessarily want to do. So now at this point, it would just be what's the cosine ratio for that. So the cosine ratio, as you can see there again from SOHCAHTOA, like the previous problem, would be the adjacent over the hypotenuse. So for this one, it would be a square root of 2 over a 2. Now moving on to number 3, where it's got a 30-degree angle, this would need a different triangle, which is the 30, 60, 90. This is just one possible way to draw it, but make sure that your smaller angle is the 30-degree one. The ratio of sides for this one would be the shorter leg is W, or you could use whatever letter you want, but I think in the notes I used W. The hypotenuse was twice that, and then the longer leg, or the one across from the 60-degree angle, was that number times the square root of 3. So for me, looking at the hypotenuse, it's already kind of a nice number, so I can choose whatever I want for W. In this case, I think I'm just going to choose a 1 in that spot, and that makes it a little bit easier. 2 times 1 would just be 2, and 1 times the square root of 3 would just be a square root of 3. So now secant, what I would need to think in terms of is what is the ratio for cosine of 30 degrees, but flip it. So the way I denote that is just by saying 1 over whatever that is. So if I can look at what cosine of 30 degrees, which would be a rad 3 over a 2. So since cosine of 30 equals rad 3 over 2, again, that's the adjacent over the hypotenuse, just like it was for number 2. But now I would just flip that ratio. So for secant of that, this is going to equal 2 over the square root of 3. And I'll go ahead and rationalize this by multiplying by that square root of 3, which now gives me a 2 square root of 3 all over a square root of 3 times the square root of 3, gets rid of that radical, but doesn't get rid of the number, so it stays a 3. So final answer for that over here on the blank would be, this is 2 times the square root of 3 over 3. Now the next pair of questions, numbers 4 and 5, just want us to practice converting forwards and backwards from the degrees, minutes, seconds format to just decimal form and vice versa as mentioned. So first one, notice it's already in the degrees, minutes, seconds format as denoted by the single tally and double tally representing minutes and seconds appropriately. So recall for converting from this format into decimal form, the whole number part, 174, stays the same. Then I'm going to add 37 over 60, and then add it with the 9, I don't know why I put 09, but 9 over 3600, or 60 squared, whichever you prefer typing into the calculator. So from here, it would just be now typing it into the calculator, which I'll go ahead and demonstrate for you, at least on a TI-84. So we would again have the 174 that I would then add the 37 over 60 added with, and then the 9 over 3600. So notice the over part, all I'm doing is just pressing the divide button, and now if I just press enter, it should convert it for me. And let's go ahead and just call that to the hundredths. So 174.62 174.62. Go ahead and get that answer on the blank just so we have a nice easy reference later if we needed to just check our answer. As far as number 5 is concerned, what we would do is know for sure that the whole number part, the 47, is going to stay. So that's 47 degrees. Then I just take the decimal portion, so in this case the 0.3684, and multiply it by 60. So once again, we'll bring that calculator up. We've got the 0.3684 times 60. That gives me a new whole number part of 22, and my new decimal part of 0.104. So this equals 22.104. So that will mean for our answer, we've got the 22, the whole number part being the minutes, and now what I'll do is just take that new decimal portion right here and just do 0.104 times a second 60. So really it's like we've done a times 60 squared, just spread out a little bit. So again, the reason we're doing multiplication is we're going the other direction. So if you think of number 4, we were dividing by 60 and then 60 a second time technically for your minutes, or sorry, for your seconds. This time I'm just going to repeatedly multiply to go the other direction. So let's go ahead and bring the calculator back up and do the 0.104, if I can remember that, times 60. So 0.104 times 60 gives us a whole number part of 6. So let's just go ahead and call that maybe 6.2 just for our final answer there. So this would be 6.24 on the calculator screen apparently, but we'll just call that 6.2 as a rounding. If you wrote 6.24, since it did end, that would be perfectly fine. And technically with one like this, I think I'll probably try and avoid this for your test, but If you just call that 6 seconds, that would probably be close enough again for what we're doing. But if you do need to round, like this example had, rounding to the tenths place usually is best practice when it comes to our seconds, at least with what we're going to be doing for our accuracy. Moving on now to number 6. This is wanting us to solve a right triangle, and it does say specifically that standard lettering has been used. So that's basically meaning, based on what we've got an A and a B. So this is more than likely just triangle ABC, where the C must be the right angle. So I'm going to go ahead and just kind of sketch that here off to the side. Got a 90-degree angle in this bottom corner, call that one C. And I'll just call that one A, that one B. I just need to have those be the acute ones. So I could technically switch those up and it would still be fine. But I do know that across the shape, because of the standard lettering, should be the same letter. So across from angle A should be side A, across from angle B should be side B, and across from angle C should be side C. So at this point it would now be, what do we know? Well, we actually technically right now can answer what angle C is, because that's where the 90-degree angle should be. And since I know it also provided me on the picture from the instructions that the angle B was 47 and the side A was 12, that I should be able to answer what angle A is relatively easy just by doing the fact that triangles should add up to 180, and if one of the angles is 90, there's only 90 degrees left. So whatever 90 minus 47 would be, which in this case would just give us 43 degrees. So I know that my angle A is 43 degrees. Again, be mindful of your units. Do your best to try and remember all of the degree signs. Not that it's a huge issue here, since we haven't really introduced the radians unit, but best practice right now is make sure if it is degrees, we use that notation, because it will become a little bit more important as we start having angles measured in radians pop up. Anywho, now from here to solve for the side lengths, the best thing that we can do is utilize SOHCAHTOA. So once again, if I just maybe write that off to the side here, I'm not going to do it the same as before. I'll just get at least those letters out so I can recognize what I need or what I have. I have the side A, and it kind of depends on which angle we want to reference, the 47 degrees or the 43 degrees that we just found. But in this case, I think if we can use the original just in case we made a mistake, that would be safer. So I'm going to go ahead and reference this 47 right here. And if I have that as a reference, that seems like the 12 would be my adjacent, the C would be the hypotenuse, and then the B would be the opposite. So it's kind of forcing my hand into solving for the hypotenuse right now if I wanted to use that one. And if I wanted to solve for the hypotenuse, since I have the adjacent, that would be a cosine ratio. So if I just said cosine of that angle 47 should equal 12 over that hypotenuse C. This one's a little bit more complex just because the C is on the bottom. So first thing I would do is just multiply both sides by that. And then the next thing would be divide the cosine of 47 back the other direction. And that should successfully get our C by itself. So at this point it would just be a calculator exercise of 12 divided by cosine of 47. And bringing up that calculator, we've got 12 divided by cosine 47. And we get 17.6-ish. So 17.6 as our value there. Oop, that was C. So, oops. All right, now solving for side B, we've got a couple of options. We could actually switch and use that as a reference, or at this point we have 2 out of the 3 and we could use Pythagorean theorem. So I'd kind of leave that up to you, but as far as just to show how each of those would work, B squared would have to equal whatever the hypotenuse is. So we just found that to be 17.6 squared minus 12 squared. And then to cancel the power of 2, we would take the square root of that result. So we could go about doing it that way. The other option we could do is just switch again, like I was saying there, over to that other angle, 43 degrees. And now look at how we could relate the 12 to the side B, which would be a tangent relationship. So I could say tangent of that 43 should equal 12 over B. And similar to what we had to do before, multiply both sides by B. divide by tangent, and I could type that in. So I'm going to actually show both just to kind of display that because we're using rounded answers, or I guess because we were using a rounded answer for the Pythagorean theorem, that our answers may be slightly off, but still should be relatively close enough that it doesn't matter which way we would go about doing it, we should still get the same answer. So showing that here as I bring up another calculator, or bring up the calculator, go ahead and clear all that stuff out. Do the square root one first. So square root, we had 17.6 squared minus, and then it was 12 squared for the other side. That gives me about 12.9-ish. If we did the other way, which was 12 divided by the tangent of that other angle, 43, as that gives me also something about 12.9-ish, but there is a little bit of margin for error. We got out to the hundredths. We had a little discrepancy, but at least to the tenths we were accurate. And they would both round up, so calling it 12.9 should be relatively safe for both of these. So 12.9 was side B. I'll do a little bit more mindful labeling there. And again, the other one also came back B equaling 12.9-ish. Again, the rounding for each of those came back close enough to each other, but again, just to explain the why there is a little discrepancy is because we're using a rounded answer for the Pythagorean theorem approach, but still, again, was close enough that all of us should be within at least a small margin of error. Moving on now to the last one of our first standard. This is now question 7, wanting us to interpret a word problem into a picture. This one does have a small little trick to it, so just be mindful of what we need here. But here it's saying basically someone from eye level, hence why it's saying from a height of about 6 feet, so a relatively tall person. So if I go ahead and just draw, okay, there's 6 feet there. Their angle of elevation to some cliff top is 71 degrees, it says at the very end of the problem, and then also says the horizontal distance that they are away, which is 105 feet, can be put on the picture, and we're just going to assume that that cliff wall will be meeting the ground at a 90-degree angle just to make this mathematically work out. So here we need to remember basically at the end that there's this extra 6 feet that I'll need to add to whatever this value is. So if I just put my unknown that it needs us to solve for, we need to solve for that x, but technically the cliff itself is going to have a value of x plus 6. So that's kind of where that little trick of this problem really gets involved. It's not intentionally it's supposed to be a trick, but it's just kind of the idea of if the angle of elevation was from their feet, that'd be a little bit weird for their eyes to start all the way down there at ground level. So it's just kind of a way for them to interpret this question into a way that would make sense as far as how someone would measure. So how tall is this? Well, let's look at how we can relate those two sides. I've got this side x and this side right here to the angle that was provided, the 71 degrees. Well, this would be the opposite side, this would be the adjacent side. So from SOHCAHTOA, hopefully we would be able to arrive at a conclusion of tangents, the best way to relate it. So it would be 71 degrees as the angle of reference, so tangent of 71 should equal that opposite side, which is our unknown, over the adjacent side, which was the 105. And similar to another problem earlier, we would just multiply both sides by that denominator to clear the fraction, and this is actually a little bit nicer than the others, where I didn't have to divide the tangent back the other way, because that actually already has isolated the x. So at this point it would just be a calculator exercise where I would just do 105 times the tangent of 71. So if we go ahead and bring up our calculator here, it's going to be 105 times the tangent of 71, and we end up getting a solution of, it looks like 304.9. So 304.9 as the x value. However, again, remember the cliff was supposed to be 6 more than that, so if I just added 6 to that, the actual cliff would become 304.9 plus 6 more, which gives us 310.9. And again, for our final answer, just because there's context to this, make sure that we're including the unit. In this case, it says foot, and actually now looking at the end of the problem, it says nearest foot, so I'm going to go ahead and just round that up to 311 feet. Now, moving on to the second standard. All the second standard covers is the non-right triangles. So this is now where SOHCAHTOA likely will not be allowed to be used unless we know with 100% certainty we have a 90-degree angle somewhere. So this does now force our approach to be more of a law of sines or law of cosines. Now, this first group of 3 questions for at least your test, these are going to be law of sines problems. And what we're going to need to worry about is potentially the either no solution, 1 solution, or 2 solution situations that pop up. So these are just a few examples. This is not just an end-all be-all, if that makes sense, meaning that not every problem is going to go in the exact same order, but I promise you each, or this group of 3 will have at least one of each when it comes to the test. So if you find one that's no solution, that means the other 2 have solutions. And as many as 2. Now, if we have one that starts in the first one, say, was 2 solutions, then you know that the next few will only have either 1 or no solution. So usually these problems are easiest if you look at what kind of angle do I have. When it's obtuse, things are a lot more efficient because it's either 1 solution or no solution. If it's acute, then that's potentially where there's going to be 2 solutions. So I'm just going to walk through each one of these and just kind of try and display at least verbally what the approach would be, and then also show as needed whatever work on a calculator needs to be done. So hopefully that clarifies everything. When it comes down to it, notice I do have, that's kind of like me not tipping my hand, I have as many spaces off to the right for 2 solutions where 3 of the parts are actually going to be provided, so just make sure you transfer that info over. But then you'll have to either find the remaining 3 things, or there may be the remaining 6 things, or if there's no solution, you can just put a big X through each of those. So again, kind of pay attention to how I'm working through these, how I'm modeling it, and that's kind of what I would expect to see as you're working through this on a test. So anyway, let's go ahead and jump into at least number 8 here. Number 8, notice we do have an acute angle, or sorry, not acute, but that's obtuse. Hello, if I could speak out loud. So this is an obtuse angle, so across from the obtuse angle needs to be the largest side. So let's just look across. Side A is the same because it's across from angle A. And if I look at it, the 19 is definitely not larger than 24, so something logically here is not making sense, right? A was supposed to be bigger than C, but in this case it actually is less than C. So at that point we can go ahead and commit to our answer here of this has no solution because across from the biggest angle needs to be the biggest side. That's not happening. So I'll just put a couple of big X's through that, box up no solution, and move on to the next question. For number 9 now, again, similar situation. We've got an obtuse angle, so this actually was a pair of questions that had a pretty easy start where it's either 1 or no. So that kind of tells me number 10 is probably going to be my 2 solution since this can't have 2 solutions. So here, again, our angle is B, so what's across from it must be side B. So I just need to make sure that that number is the largest. If I compare that with what A is, since B is greater than A in this case, and that's what I needed, this actually does seem to have a single solution. So I'm going to go ahead and just kind of note for myself there's 1 solution, and I can go ahead and maybe commit to that and just say over here I don't need this second blank with the other ones. Now I may as well just take the given info and transfer it over there. So we know that the B value was 116. I'll go ahead and do those in a slightly different color just so they don't draw as much attention as the actual answer. We know that side B is going to be 23. And we know that side A is already 12. So it looks like I need to figure out what the 2 angles are and the remaining 1 side happen to be. And everything from here, again, this is a law of sines problem, so I'm going to go ahead and just kind of set up the ratio I know. I have both B's, so this is going to be sine of 116 over 23 is like my root of everything here. So since they gave me the side A, it kind of forces my hand into solving for angle A to start. And then once I have that angle, I should be able to figure out the angle C. And once I have the angle C, I should be able to find that last part, side C. So it kind of is forcing my hand into a number 1. I'm going to solve for A. Number 2, I'm going to solve for angle C, and then number 3, I'm going to solve for side C, if that makes sense to you. Off to the side, that's kind of the route this problem, as far as it's being presented, is concerned, is going to force me through. So let's go ahead and do the solving for this. It's going to be the 2 where I can cross multiply, so 12 and the sine of 116, and then divide by the last number. And since this has got sine of A, eventually the next step is going to be, let's cancel the sine. And I personally like doing this all at once on the calculator instead of trying to come up with multiple decimals and then use those new decimals to come up with the next answer. To me, it's easiest to just type it on all at once. That way the calculator, 1, keeps everything precise, but 2, I don't have to worry about writing down a whole bunch of ugly decimals as I work through the rest of the problem. So as we can see here, it would just be the cross product and then quotient, so 12 sine 116 over 23 as mentioned before. Then to cancel sine, I would just take its inverse, which is called the arc sine, and now type everything on the calculator. So if I go ahead and bring that calculator up just to model this, I'll go ahead and clear out all that stuff from earlier. And here it's going to be the inverse sine, so second of sine. And then I would have on the inside, I had 12 times sine of that angle, 116. Close that off since it did open a parenthesis, and then divide by the other side, 23. Close the parenthesis there, press enter, and notice it gives me approximately, well, if we round that to the tenths, the 6 would make the 9 go up, so that's actually just going to be 28 degrees. So back to our answer here, this comes back about 28 degrees. So we can put that in our answer blank over here, and now that should kind of unlock the next part, which is going to be pretty simple. The third angle. Recall, triangles have to add up to 180, so I'll just take the 2 angles I currently know, 28 and 116, subtract them from 180, and if we go ahead and again bring that calculator back up and just type those in, I'm going to get 180 minus the 28 minus the 116, and when I press enter it gives me a 36 degree angle, so 36 degrees, and commit to that on my answer key. To solve now for that last side, I just go back to that original ratio of sides that they provided me, the sine of 116 over 23, but this time I actually know an angle. This will be sine of that C, which we just found to be 36 degrees, and that should help me solve for side C. And like we did before, it's going to be whichever 2 I can do the cross product of, so 23 and sine of 36, and then divide by whatever is left. So for this one, C is going to be equivalent to 23 sine of 36 over sine of 116. And again, I just like typing it in all at once, so let's go ahead and bring that calculator up. I have 23 times the sine of 36 divided by the sine of 116, and pressing enter on that gives me a side length of 15. So we'll go ahead and call that 15 over here and commit that to my answer blank over here as well. And notice this one does not have degrees, just because, well, that's a side length. Now, one thing you can do to double check your answer here, at least to see if it's logical, is across from the smallest side needs to be the smallest angle. Across from the biggest side needs to be the biggest angle. So if we just do a quick little double check, angle A is the smallest and side A is the smallest, so that at least checks out. And then angle B was the largest and side B is the largest. So that seems to be checking out. So at least our answer, logistically speaking, makes sense for at least the kind of numbers that we should have. All right, so last one, number 10, we've already kind of narrowed this down. As I mentioned, there was going to be one no solution, one single solution, and one two solutions. So this one must be, by process of elimination, the two solution one. But let's say we didn't necessarily know that. I'll still model it the way that we should. So here, why this potentially could have two solutions is that is an acute angle. So what I would do is kind of just draw my little hangman triangle as we've done in class, where I don't know if that side length across from the angle that I'm going to label down here, which is side A, or sorry, not side, but angle A, I don't know if that side across from it, side A, is long enough necessarily to, for sure, close off that triangle. So I do know it has a length of 28, and then I'm just going to use whatever the other side length is for our connector here. That must be 29, so if it does close off, that must be angle C in this bottom right, which then tells me this must be angle B at the top and side B down here at the bottom. But again, I don't know for sure if with 100% certainty that actually is going to be far enough. I feel like it probably is because it's really darn close to 29, so it probably can. But the fact that it is less than 29 means it technically could come back towards the left or down and to the left instead of down and to the right. Hence, again, this is why it could potentially have the two solutions instead of only a single one. Now, if that side across, let's say that 28 was actually like 38, then this would for sure be a single solution because the only way it could go is down to the right, and that's for sure going to be long enough to overcome the height because the height actually is less than 29. So if the side across was already bigger than 29, for sure it would have been a single solution. So again, just trying to point out, let's say on the test maybe it wasn't in the same order, which I don't know. It kind of depends on which version of the test we end up taking, whether it's going to be like a same order as this or if it's going to be slightly different. So it's possible the first group, like number 8, could have been the 2 solution, or maybe even number 9 could have been the 2 solution. So again, don't try and memorize like, oh, it went no solution, 1 solution, 2 solution. That's not necessarily always going to be the case. Just look at the numbers, look at the facts, and see what's there. Here, if I go ahead and just come up with what this height is, the height will always be the adjacent side, 29, times sine of whatever the angle is, which I didn't put on the picture, but that was 48 degrees as it was provided, so it would be sine of 48. And if I go ahead and type that into my calculator here, bring that back up, I've got 29 times sine of, that one was, I already forgot the number, 48, there it is. And press enter, it's 21.5, which definitely 28 is large enough to overcome that 21.55 if I want to be a little more specific. But for sure, again, that 28 is large enough that it can go each direction. So I'm going to go ahead and just say this does have my 2 solutions. One of them is going to be the triangle that goes down and to the right. I didn't draw that very well, sorry about that. Or I've got my 48 degree angle here. I've got, this is going to have 2 different B values, so I'm just going to start utilizing some subscripts, and it's going to have 2 different C values, at least for the angle. And then I know that this side over here is 28, I know this side over here is 29. So for sure, since this has the 2 solutions, I can at least get the numbers they provided to me on my answer off to the right. So 48 degrees is my angle A for both of them. I know that my side A is 28 for both of them, and I know my side C is 29 for both of them. So again, I've got kind of that angle B, angle C, and side B that I'll need to figure out. And one thing to take note of is the C here from this first solution. If I go with, here's what my second solution is going to look like, it would be the one that actually comes back down to the left. This C2, if you recall, because of the idea of having this kind of empty triangle, if I were to kind of sketch it off to the side here, this empty triangle, basically this angle and this angle would match, but I need the angle that's inside. So again, because that's making a line, it's just going to be, for C2, this is just going to be 180 minus whatever my C1 is. So I'll just kind of take note of that off to the right. That's going to be kind of the key to my second solution for that. So kind of just thinking ahead, that's how that's going to work out. So I don't know, I guess I'll get rid of that just so it's not as distracting, but just to explain the why it's 180 minus C1, hopefully that helped out. So anyway, we'll go ahead and jump into this. Again, is a law of sines problem. So the ratio I know is the sine of 48 over 28. I'm going to use that for pretty much everything that comes from solving using law of sines. And once I have this, that seems like I have to solve for, since I was given side C, I'm going to have to solve for this first C1 using 29 as its base underneath. So again, cross multiply the 2 that I can, divide by the result. And in this case, I'm going to go ahead and kind of skip ahead because I need to cancel sine. I'm going to do the inverse sine. Anytime we solve for angle, we have to use one of those inverse functions. In this case, it's the arc sine as its special name. So again, the two cross products were 29 times sine of 48. And then I can divide by the last side, 28, but it's all inside of an arcsine function. And if we go ahead and bring that into, or bring the calculator up and type it in, we should be able to get our solution. So clearing out what we got there, let's go ahead and type that in. So we've got the inverse sine of 29 times sine of 48. Close that off, and then do divide by 28. Again, notice I'm just typing it all in one single line instead of breaking it into multiple parts, and I get 50.3 approximately. So 50.3, which then if we go over to our solution on the right, we can go ahead and say that angle C is 50.3, which then means I've got 2 out of 3 to utilize to my advantage. So off to the left here, I'm going to just say that B1 then must be 180 minus those 2. So minus 48 minus 50.3. And that gives me, if I bring the calculator back up again, 180 minus 48 minus 50.3. And I get my last angle to be 81.7. Add that to my answer over here as well. And at this point, might as well go ahead and solve the rest of the way for that specific triangle. So again, utilizing the law of sines, I'm kind of running out of space here quickly, but I've got sine of 48 over 28 that once again I'm going to keep using since that was the two things that were provided, and that should equal sine of the angle I just found, 81.7, over, and then this is the first side B to complete my first solution. So again, cross product and quotient, and I end up with B1 for this one equaling, it looks like I've got 28 times sine of 81.7 all over sine of 48. And bringing the calculator back up again, typing in, I've got 28 sine 81.7, close it off, divided by sine of 48, close that off, press enter, 37.3 approximately. So 37.3. Guess I did say technically to round to do 2 decimal places in the instructions, so I should probably model as such. So 2.8 actually. So erase that 328. All right, so put that as my committed answer, and again we can look at the logistics of that. Across from the biggest angle should be the biggest side, so B is the largest, side B was the largest, that's good. And smallest angle is A, small side also was A, so at least that checks out. Now the key to my second solution again was the whatever I found first, which was angle C. Its supplement, so 180 minus that, should be the other C. So if I did 180 and I subtracted the 50.3, that should give me a 29.7. Sorry, a 129.7. I don't know why I said 29.7. Definitely need to be a lot larger. So 129.7 for that value, which again, now similar to what we had with our first solution. We now have 2 out of the 3 angles, so we can go ahead and find the third one pretty quick. So let me just draw a little separator here. So I can do B2 is just going to equal 180 minus the 48 minus the 129.7 we just got. And if we go ahead and bring the calculator back up for that one, again 180 minus 48 minus 129.7, and we get 2.3 degrees. So a really tiny sliver of an angle here, 2.3. So the last step now is just going to be fall back to that original law of sines ratio that we can use. So I've got sine of 48 over 28 being equal to now sine of that angle I just got, which I don't know why I didn't put degrees on those yet. Sorry about that. I've been trying to stress it and then I'm not even modeling it. So here we go. We got 2.3 degrees as the angle on the inside. This part, it doesn't really matter because I'm just going to solve by typing into the calculator anyway. But here again, it would be the cross product. So here it looks like I can do 28 times sine of 2.3 and then divide by sine of 48. So it's virtually the same as what we typed in to finish up the first solution, except my angle has changed. So I could go up and try and copy and paste, but it's not that beneficial. I can just type it in just as easy. So 28 sine of 2.3, close that off, divided by sine of 48, close that off, and press enter, and I get 1.5 as my last side there. So 1.5, really tiny one, which kind of makes sense because if I had it come back a little bit, as we can see with this one, that was seemingly going to be a pretty small side length. So the fact that that is a lot smaller than the other one makes a lot of sense. But again, we can do our quick double check. Across from the biggest angle should be the biggest side. Across from the smallest angle should be the smallest side. So it looks like our biggest angle C is definitely across from the biggest side, and then our smallest side B was definitely across from the smallest side as well. So everything logistically seems to be checking out. A little too far. Moving on now to numbers 11 and 12, which essentially are going to have us utilize law of cosines. Reason being, we have the first one is a SSS situation, whereas it looks like the number 12 is an SAS situation. Kind of the dead giveaway is I have 3 different letters, and only one of them at most was an angle, so for sure it's going to be a law of cosines. Sometimes if I have all 3 letters but 2 of them are angles, that would just turn into a law of sines problem, just to clarify. But for sure, again, law of cosines is what I'll have. So number 11, if we look at what we got, it's already provided 3 of the parts for our table off to the right, so we may as well just get those locked and loaded with our answer. Just transferring those over to where they should go, and then now it's just going to be pick an angle and solve for it. So for this first one, I think I'll just go alphabetical. I'll go with capital A. So since I'm solving for an angle, I'm going to have to use an inverse trig function, in this case the arc cosine, or the inverse of cosine. And what I do know for sure is at the very end of this fraction in the numerator, it's going to be minus. Since I'm solving for angle A, I need to subtract the side A. So for sure it's going to be minus an 18.3 squared, and then the other two, doesn't really matter the order. I just have 16.2 squared added with 16.7 squared, and then on the bottom it's just a 2 times each of those same 2 numbers, 16.2 and 16.7. And if I go ahead and type all that into a calculator, which let's go ahead and get that up on the screen. I'll go ahead and close out what we got and just kind of model how I could do this. So it's going to be, again, all in one fell swoop. So I do second of cosine to bring the inverse cosine in. Then it's going to be the fraction template just to make the order of operations a little bit easier. So alpha, y equals, press enter. And at this point, type in what we got. So I had 16.2 squared first, added with 16.7 squared second, minus the 18.3 squared. And then on the bottom, I just had 2 times the 16.2 times the 16.7. And at the very end, I can close off just by pressing to the right to get there. Press enter, and it gives me that last, or that first angle, I guess, that I'm getting here is a 67 point, and I think in the instructions I had it to the 10th, so 67.6. So equals 67.6 degrees. And may as well include that on my answer portion over here since I found it. Now ultimately all I have to do is really just find one more of those angles, and then I can take advantage of the adding up to 180. Kind of no matter what I do, I'd more than likely have to use one of my prior answers anyway, so may as well just trust that I'm doing the first 2 angles correct to come up with a third one. So I think I'll just continue alphabetically, figure out what angle B is. And basically it's going to be the same formatting. I've got this big fraction on the inside of an inverse of cosine. I know because I'm solving for angle B, I need the last side, or the subtraction at the end, to be just subtracting side B. So that side was 16.2, so it's going to be 16.2 squared in that spot. And then the other two numbers, doesn't really matter the order, I'll go 16.7 squared plus the 18.3 squared. And then on the bottom, 2 times, again, those same two numbers, 16.7 and 18.3. And so once again, bring up the calculator. And we've got the inverse cosine of, and then I've got my fraction template. So again, alpha y equals first option. And since we're solving for that last side, it looks like I've got first the 16.7 squared plus the 18.3 squared minus the 16.2 squared all over 2 times 16.7 times 18.3. Go to the end, close the parenthesis, and here we go. We've got 54.9, it looks like, for this one. 54.9. And so now it would just be take those two answers and subtract them from 180. So at least to show the work over here, it would just be 180 minus each of those. We could technically do the exact same thing we've been doing so far, but me, it feels like typing that into the calculator, what I just did there, would be significantly easier than doing another arc cosine of that big long fraction. So let's just go ahead and bring that back up and figure out what that will be. So 180 minus the 67.6 minus the 54.9, and we get our last angle to be 57.5. For number 12 here, just like I mentioned not too long ago, this one will be law of cosines again because 3 different letters in single angle. This one is probably just as beneficial to go ahead and fill in what we know over here on the table. So fill in our side A, side B, and then angle C. So this one's kind of forcing me to solve for what side C is first. So I kind of have to do this one first, and then it really won't matter between A and B which one I solve for next. But once I have 2 of the angles, I can get the third one just by subtracting the other 2 that I know by or from 180. So again, I kind of forced to solve for this little c first, so let's go ahead and get the ball rolling on that. So this would be c squared normally equals all of this stuff, but since it's a power of 2, I may as well just take a square root to cancel that power. So now c equals, and then it's the other 2 sides that I know, so 19.1 squared added with 18.4 squared minus twice their product, so twice 19.1 times 18.4, but also times the cosine of the angle that we're referencing, in this case the 84.2, to be able to allow us to solve for that side C. So at this point, again, just all of this will turn into a type into the calculator situation. So let's go ahead and bring that up. I can't find my mouse. There we go. Clear out all that stuff just so it's not as distracting. So this will be big square root, so a second of x squared. And then on the inside, just typing in each one of those. So 19.1 squared plus, the other one was 18.4 squared minus 2 times those same 2 numbers, 19.1 and 18.4, but also times cosine of the angle, which was 84.2. If I close that off, press enter, it comes up with a 25.14, so 15, so 21.15, or 25.15, sorry. And that would be my third side. Sorry, I'll keep it color coordinated here. 25.15, there we go. And now that I have that third side, I should be able to solve for either A or B. I think I'm just going to go after A. So this will be the same as what we just did on number 11. This will be the arc cosine of, and then I got this big fraction. It's angle A that I'm solving for, so at the end it just needs to be side A squared after the minus sign, and then it's the other 2 numbers that I know squared and added prior to that. So 18.4 squared, and then what I just found, the 25.15 squared, then over 2 times the 18.4 and the 25.15. And if we go ahead and switch back again to the calculator and type that in, we've got the inverse of the cosine. So arc cosine, bring in that fraction template, alpha y equals first option, and typing in what we just had, 18.4 squared plus 25.15 squared, then minus the side that we needed across from the, side that we needed across from the angle, 19.1 squared over, and then 2 times the first two numbers, 18.4 times 25.15, and close it off just like we did before, and we get our final answer there to be about 49.1 for this angle, 49.1. And if we know that that one's 49.1, we can then just angle B, and just be 180 minus those two numbers that we already know. So 180 minus what we just found, 49.1, minus the angle they gave us at the beginning, 84.2. And once again, bringing that in on a calculator. 180 minus 49.1 minus 84.2, and we get 46.7. Each of those need to be degrees. I think I forgot those on the ones prior, but should always have the degrees marks. I think I'll make sure it's on the answer key for you, but yeah, we got one problem left to go. Go and jump into that one. 13 just wants us to find the area of the triangle. This one appears to be the SAS situation, so I don't have to worry about the semi-perimeter one, the one with the S. This is just straight up 1/2 the two sides I know times sine of the angle. So the area for this one, since I had the letter A, I'll just use the word. So it'd be 1/2 my two sides, 14 and 5.6, multiplied with sine of the angle, which is 96. So at this point, let's bring that calculator back up one more time, and we get the 1 divided by 2, or you could even just write that as 0.5 times 14 times 5.6 times, and then sine of 96, and we get a value of 38.98. So I'm going to just round that up to 39 square units. I'm not going to be too picky, but because this is an area, just trying to at least recognize that this should be a different kind of unit than what we're starting with. In fact, actually, it gave me units. I'm glad I just caught that. That shouldn't be just unit squared. We can go ahead and call that centimeter squared. So just be mindful if they do provide, which I'll actually try and make sure that it does, some form of unit, makes it a little bit easier to just write that it's a square unit because it's area. So anyway, hopefully this video has been helpful. If you have follow-up questions while you're working through it, please just come find me, give me a chance to help. But yeah, again, thanks for your time watching the video. We'll catch you next time.